This video is going to take you through two Ellipse applications. One is the whispering gallery, where if a person stands on one focus point in the room and speaks, the sound bounces off the semi-ellipse ceiling, and the other person standing on the other focus can hear them. Technically, it should be in a whisper format, so in a normal situation, they would not be able to hear if they were on that side. So in this scenario, we're looking at the picture, which I'm just going to redraw what's happening here. We're assuming both of these people are 6 feet tall. I mean, that may not be the case, but just for the purposes of this picture, we can actually tell our B value, our distance from our imaginary center of the room of 0, 0, is 20. And the A value, so the whole distance is 50, which means half that distance is 25. So our A value is 25 because that's the longer one for the ellipse. So if we were writing the equation, although you don't need the equation to solve this scenario, your equation would be x squared over 25 squared, or 625, and y squared over 20 squared. Since the numbers for these tend to get a little bigger, you don't always have to actually square them. You could just put squared as part of your answer. Now, we want to figure out where we should be standing. So use the information to figure out where the foci are located. So we really just need the C value. C squared equals A squared minus B squared. So C actually is going to come out to 15 feet from the center. Now, if you can't figure out what the center of the room is, we want kind of a reference point. So if we think about this being at 15, 0, we're actually 10 feet from the wall. So you'll notice with these applications, with the ellipse or hyperbola, we want to use reference points that we can actually find. So you would walk in 10 feet from the wall to the focus point. Usually in these whispering galleries, the focus points are labeled so you know where to stand. There's one in Washington, D.C., and actually one in Grand Central Station also. All right, and then semi-elliptical arch bridge is another scenario. Here, we're given the picture off to the side. Very similar. We have our B value as 6, and our A value is half of that total distance of 10, so it's 10. This one we are going to need the equation for, but normally I just write it anyway in case we need it. So this would be x squared over 100 plus y squared over 36 equals 1. Here we want to figure out, well, it says write the equation, and then it says how high will the bridge be over the water 5 meters from the side. So if we think about where that's going to occur, again, here's my imaginary 0, 0, here's 10. 5 meters from the side is actually going to be 5. So you want the height there at 5, y. We're going to plug in our values. So we're going to plug in 5 for x, and then solve for y. So in the calculator, I would plug in 1 minus 5 squared over, I could put in 25 even, it's kind of silly. 1 minus 5 squared over 100. Multiply that by 36. Then take the square root, so it's square root of 27, which is approximately 5.2 meters high at that point. And sometimes it will be asking, like, will a certain height of a boat or something like that clear that height, but for now it's just asking what the height would be from that distance. This one happened to be equally spaced, but it may not always be that way, so make sure you're using your vertex as a reference point and then subtracting off when it does reference the side of the room or the river or whatever scenario you're looking at. The other application scenario that you will look at when you do practice is the elliptical orbits. With that, you're going to be using a set picture and kind of manipulating the numbers to work for that. So it's a little different, but you're going to kind of try that on your own. There will be some whispering gallery and arch bridge questions as well.